Hello everyone, this is a projectile motion problem we have today. So we have this question number 7. So I've taken this question from this site right here, and they have a whole bunch of other questions. They have the answers too. So let's just figure out this question right here. So we have a bullet that was fired at an angle of 60, and we have given the initial velocity and how long was the bullet in the air and what is the maximum height. So we're trying to find the time and trying to find the maximum height. So let's just say that this was going like this. A bullet was going up and then came back down, so that is here. And so it was fired up, let's say it was fired up with a initial velocity of 200 meters per second at an angle that is 60 degrees. And so how long was the bullet in the air? So to do this, first we have to figure out the x and y components. So we can say that's your x component, that's your y component. We have the VIX, we have the distance, and we have the time. Here we've got the VIY, we got the VFY, the acceleration, the height, and we've got the time. So we know that the acceleration is negative 9.81 meters per second squared. We know that the initial velocity is going to be 200 sine 60. We know that the here it's going to be 200 cosine of 60, because if you broke it down, the velocity into its x and y components, that's your VIX, that's your VIY. And so we know that the VIX doesn't change, so if you want to do this, that just 100 cosine is half, and that is going to be 100. And so we could figure out the time by just assuming that if it goes up, it has to come back down. And so if it came back down, that means it started the same point, it's going to end at the same point because it's not a cliff or anything. So your height is going to be 0 meters. 0 meters. So it's not going to change. And so this is what you have right here. So that's to find the time. It's pretty simple. We just use this equation right here, which is that h is equal to VIT plus 1 on 2 AT squared. So here we know that this is going to be 0 is equal to 200 sine 60, and then that multiplied by time plus negative 4.905. So plugged in negative 9.81 divided by 2, and that there's here going to be t squared. So for this one, it's going to be 0 is equal to 200 sine of 60 is equal to 200 sine 60 is equal to 173.205, and then I could take out a t here, so minus 4.905 t. And so divide by t, so this goes out, move this over, and then divide. So t is going to equal to 173.205 divided by 4.905. And so your time is going to equal to, so you got 173.205 divided by 4.905. So this is going to equal to 35 point, let's say 312 seconds. And so here is your time. So we know that this here, so we've got the first part done. So what is the maximum height reached by the bullet? So what is the maximum height? Again, it is from here. The maximum height is from here all the way here. So that's your maximum height. So how can I figure out? So the maximum height, we know that the VFY is going to equal to 0 meters per second. We know that the VIY was equal to 173.205, right? And we know that your acceleration was negative 9.81. And so we could use this information to figure out the height max, and that is equal to what? So to use this, we have to use the different equation, that is this one. So VF squared is equal to VI squared plus 2AD. So this is going to equal to, so we know that this is going to equal to 0. 0 is going to equal to 173.205. That's going to be squared plus 2 times negative 9.81, but instead of D here, I'm gonna have an H, so that's your H right here. So that's 0 is equal to 173.205 squared, and that should equal to 29999.972, and then minus 1.62h. And so we could move this over to the other side, so and then we could divide, so your h is going to equal to 29999.972, and all of this is going to be divided by 1.62. And so your height, so if you want to incorporate this, so 21234.972 divided by 1.62, and so this gives you a height of 172.451. And so this is your height right here.